Question C. We come now again, this is to the circuit diagram that we started off this particular session with. We have cell or battery in series with a variable resistor, in series with an ammeter, in series with a component and a switch, and then a voltmeter across the component. And that is the essential circuit that you need to know for investigating the current voltage relationship. Now this time they've given you that and they're asking you to look at some results, but in previous questions they've asked you to draw that circuit, so you must learn that circuit. And the component here could be a wire, it could be a diode, it could be a bulb. You have to look at it and see what exactly it is. Okay, so we've produced a set of results here with a graph. The graph, you can see here, it goes across straight, and then when it reaches about 0.6 it starts to conduct, current is flowing, and then it moves out. So the component that we have here, this is a typical curve for a diode. The explanation for that is, well, it conducts only, it conducts when the PD is greater than 0.6. Okay, so around about 0.6, 0.7 that we would say. So when the PD is greater than 0.6 volts, or you could say it doesn't conduct until a certain voltage is reached, something along those lines. So it conducts only when the PD is greater than 0.6. So no current flowing, and then all of a sudden it starts to flow, and then it has very little resistance at this point. So that's a diode, a feature of a diode. The next component graph that they show is fairly straightforward, straight line through the origin. So the component there will be a metal conductor. Okay, so a metal wire is what we have there. The explanation, because V is proportional to I. And remember, that's what Ohm's law states, that the current is proportional to the PD, or the PD is proportional to current, provided that the temperature remains constant. Another way of looking at that is to say that resistance is constant throughout. And then the final graph that they have shown, and we didn't need to just be current, to be careful with all of these, because we have current on the y-axis and voltage on the x-axis. Quite often we would put these round the other way, but this component then is a filament bulb, and that's because the resistance is getting bigger, right? So it's getting less and less steep for here, and because it's current voltage, it's 1 over the gradient that tells us the resistance. So we have less steep there, which would give us a bigger resistance. So the resistance increases with voltage. So that indicates that it's something which has a metal filament in it which is heating up, and the resistance is changing, the resistance is increasing.